with trig functions, so you can see how they're used. This is on model rockets. It says to calculate the height h reached by a model rocket, you move 100 feet from the launch point and record the angle of elevation, which we're going to call theta. Theta is kind of like using x. It's like a variable, but it's the variable they always use for degrees of angle. To the rocket, an elevation of theta to the rocket at its highest point. The values of theta for 3 flights are given below. Find the rocket's height to the nearest foot for the given theta in each flight. Now it stands to reason that the more angled the rocket is when it takes off from the ground, the lower it's going to be at the arc when it tops out and starts back towards the ground. Okay, and there's no way for you to measure this height. So theta is our angle, and it can change, and it's for each flight, so it's 77 degrees for the first one. And so you're going to look at theta and say, okay, I can use my tangent ratio because this is my long leg, and it's opposite theta, and this is my short leg, which is the adjacent. Of course, this one is the hypotenuse, and we can't use that for our tangent ratio. So you can write one equation that will work for all of them, because you're going to say tangent theta is equal to the height that you reach over 100. Now to get the height by itself, you're going to multiply both sides by 100. So this is your base equation, okay, for those of you who just like to write the equation, and that cancels out. Now we can just substitute in each of our degrees for theta, each of the angles that for each of the trials of flights. Okay, so using the Texas Instruments for now. Okay, so we're going to say 100 times tangent. Our first angle is 77 degrees. Tangent 77 equals 433 feet. Now it says find the rocket's height to the nearest foot. So we're going to ignore the decimal point 1, and we're just going to, well, we're not going to ignore it, we're going to round it. So this is 433 feet. Now once again, I need to see this equation. Okay, now to find theta 81, we're going to substitute in 81 in place of our theta, and we get 100 times tangent 81, sorry. And I get 631 feet. It's amazing how much of a difference a few degrees made. Okay, then we're going to substitute in 83 for theta, and we have 100 times tangent 83, and we get 814 feet. And that's our word problem on rockets. Okay, now for video number, it's not 16, for video number 6, we're going to find out how to use the